common data. PubMed is a common database that all of us use. So while we are piloting our search strategy, we go to PubMed because Google Scholar and PubMed are the two common free platforms. But Google Scholar, the search strategy is the advanced search feature is not very good. So when we are devising our search strategy and giving a trial run in PubMed, we should see that we do not get thousands of articles because as you would see in the later sessions, all the articles that we get from each database, say I searched, I will show you with an example. So suppose if I search, I want to search on oral lesions in monkeypox. This is the topic that we were talking about in the previous two sessions, so I'm continuing on it. Suppose our topic is prevalence of oral manifestations in monkeypox virus patients. So if I just write monkeypox virus patients, I am getting 263 results. This is because it's a rare disease. Say if my research question is effect of metformin on weight gain in diabetics. So I have to search for this specific thing, this drug, what effect it has on weight gain or weight loss in diabetics. So if I just write metformin diabetes and I search, I am getting 19,370 results. I will repeat this. I have to repeat this search in Scopus, Web of Science, and several databases. The more number of databases you use for your SRMA, it is considered to be better. It is thought that there's a less chance of you missing some article. So if I use some other database, I may again get 10,000, 15,000 results. I will club them. The number of results may touch 1 lakh if I don't use a proper search strategy. Then you have to actually manually screen each article. You have to screen each article by their title, by their abstract, and then see which are provisionally eligible. Then we have to check the full text of the provisionally eligible articles and so on. Therefore, we should be very specific in our search strategy. We should get, I mean, the article shouldn't cross 3 digits because say if you get 10,000 results, it's not humanly possible to complete the screening for all those articles. So either you are not doing the process correctly, or if you do it, it will take so much time that your article will get very old. Therefore, we should be very specific in our search strategy. For example, this same thing, if I would have limited it to, okay, I will start again. Once you go to PubMed, I hope all of you know that we can click on advanced.
Sorry, sir, your voice is breaking.
Okay, I will try changing the earphone. Is my voice better now?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you. Once you have reached the home page of PubMed, as all of you may know, we have an option for advanced search over here. This is a very useful feature. We will click over here on this advanced button. Now, this is our home page for advanced search. Here, I can write, I can actually break the research question into several components. You may have already done so in the Pico format earlier. So say if I was searching for the same question, metformin, weight loss in diabetics. So I will write metformin. I will click add. I will again write something like weight change and again diabetes, because I only want to see the effect of metformin in diabetic patients. It may be used in other diseases like PCOS, but we are not assessing this for this specific article. Once we click all of this and search, you can see that we are getting only 1833 results. This is still a lot. We can decrease it further. But the thing is that when you specify and you use these Boolean operators, it decreases. We will reduce it further. What we will do is that uh, in this field, we will click on title or abstract. You can see it is the third last option, title or abstract. Now what happens is that, say if I search like this, only those articles which have the word metformin in the title or in the abstract will come in the results, and those articles which don't have this word in the abstract but somewhere in the full text, they won't come. So if we want eligible articles, I mean, if the research question of our article is not even mentioned in the abstract, the keyword is also not, if the keyword is also not mentioned in the abstract, it is highly unlikely that that article will be of any benefit to us. Therefore, we will restrict our searches to only articles which have this keyword in a title or abstract. What happens is that, say, you may have an article on Voglibos in diabetes, and somewhere in the discussion section, they may have said that Voglibos has a worse adverse event profile than metformin. So that is something that they have mentioned about metformin just in the discussion. So we want to exclude those articles. We only want those articles that are focusing on metformin so that we can include them for our SRMA and extract the required data. So we will repeat this same search but with this change, that is title or abstract. I have written metformin. Now we will write weight change again as title or abstract, and then diabetes. Now if you may have now if you see, this same thing has gone down to 115, from 1833 to 115. That's almost a 15 to 16 times decrease. Now these number of articles we can manually screen. We can manually screen the title and abstract of each article. The ones which seem relevant, we can then search the full screen. We can search the full text and so on. So this is how we come up to a more specific search strategy.
ఏమండి వేడిగా ఉన్నది, అది వెయిట్ చేయండి కొంచెం, కొంచెం వెయిట్ చేయండి. ఐ ఫీల్
Now, but what is the problem with this search strategy? Can any of you tell me if there is any problem with this search strategy? What is the disadvantage?
We can't correlate between metformin and diabetes. Like weight change, if it is not there in the article, it won't show.
Yes, sir, you're right. But our research question was, what is the effect of metformin on weight in diabetes. This was our research question. Therefore, we are only weight is our outcome. The population is diabetic people. The intervention is metformin. The outcome is weight. So that's not a problem. We want to restrict to only those articles that show weight change.
Sir, not all studies will have all these keywords. Sometimes it may be synonyms of the same.
Yeah, that is one issue. So an example here could be that diabetes may instead be written as, some study may say, effect of metformin on weight in diabetics. Some study may instead use this word. Instead of diabetes, they may say diabetics. So those studies may get missed. And that is like, especially if your SRMA has little studies, has few studies, we should try to include all the available studies. We should try our best. We should avoid missing out. So we can again, now an easier way of doing this is that I will just write metformin, add to history, weight change, add to history, and diabetes or diabetics. And after doing this, you can see that in the search number 5, I searched for metformin in title or abstract and got these many results. In search number 6, I searched for weight change in title or abstract and got these many results. I searched for diabetes or diabetics and got these many results. Now I will combine these three. The same thing that we did here, we are doing here. It's just that instead of typing these full things, we are calling the specific searches. Now you may see that in this specific example, we had 115 earlier, we have 115 even now. So probably there was no study that used the word diabetics. But there are certain examples where this increases. Another thing that we can do is we can modify this search number 7 further. There may be some study that may have used the word diabetic instead. Like they may not have said diabetics. They may have said something diabetic nephropathy, diabetic retinopathy, or diabetic without an S. So we'll try to include them also. I will just delete some things for more clarity. And now compare 7 and 9. You can see that just by adding the word diabetic, the number of results increased from 648 to 751,000. And this is a significant increase. And this is important because many studies that may have used the word diabetic, we would have been missing out on those studies by this search strategy. Therefore, synonyms or even within the same word, if there are different ways that the word is written, different forms of the word, like say noun, adjective, or like that, we should try to include even those words in our search strategy. An easier way to do this is that, like we had seen, we had three things: diabetes or diabetics or diabetic. We can instead write this. What does this asterisk sign specify? This is a sign of truncation. What it many of you might already know, but for the others, what happens is that now whatever characters are there after T get included. For example, if I write diabetes, since it has D, I, A, B, E, T, and something after that, it gets included in this. If I would have written diabetic, this also gets included. If say I'm just making up a word, if I wrote something like diabetes, something, some word like this, even this word would get included in this because DIABET is there. So instead of having to manually think what are the different forms of this diabetes word, like diabetes, diabetics, diabetic, we can simply write it as diabit and put an asterisk mark. It then searches for all the forms of this word, like wherever you have these 6 characters and something or nothing after that. No,
Sir, can I ask a query?
yes.
So when we write weight change and search in title and abstract, so will we miss out those which are reporting like weight gain or weight loss?
That may also occur.
So
Though the
we have to,
chances are less because I did not put weight change at a double apostrophe.
okay.
So
So it will,
chances are
if
less,
the
but
word,
still that may happen, and therefore that is what I was going to tell later. Okay, weight change, weight gain, weight loss, and all those things can all be replaced by just the use of single word weight.
okay, so it will like weight and change will be searched separately when we write weight change without apostrophe.
What happens is, suppose in the first sentence you have a word called weight, and in the fifth sentence you have a word called change. As far as I know, even that will get included over here.
Okay, suppose there is only weight, like no weight
Huh.
change, but weight and loss, then we're likely to miss.
Then it is likely to be missed.
Okay, but we have not put it into bracket even then.
Yeah, even then. So that is what I'm saying. If the article, if the abstract has say weight in the first paragraph, wait a minute. Suppose the abstract has weight in, say it has written ki the average weight of diabetes patients is 10 kg, and somewhere down the line they have written change in fasting blood sugar was 25 mg per dl. So weight came in a separate sentence, change came in a separate sentence, but since both of them are in that abstract, that may also get included in this, even though it is not in a double apostrophe. I hope I'm clear.
Significance of double apostrophe. What is
Double.
the significance of double apostrophe?
Okay. Okay. We'll see with an example. Okay, it's coming like this only, but in certain cases, I remember ki double apostrophe changes this. Wait a minute. See and you can see a good example here. That in some cases, like it was not happening with title abstract, but when you are searching normally, what is happening is that with double apostrophe, you're getting only 8,000 results, 8,800. But without double apostrophe, you're getting 213,000 results. So adding this uh, narrows down your search results. This is the difference between double apostrophe and not having. Here, what happens is that it searches for the word weight and also searches for the word change. But here it searches for the exact phrase weight change. They should be next to each other, the words. Only then it gets included. So we were in diabetes, right? I will remove this for clarity. So now these three are what we're focusing on. So even though we had three different forms of the diabetes word, we got 751,000 results. And when we changed it to a truncation form, we got more results. Why is it so? Because there might be some other forms of this word that we could not think of. Therefore, it is always safer to use this truncation because there will be many forms of the word. So we have covered truncation and we have covered dividing it. So for weight, so instead of weight change, we can just search weight in title abstract. Again, we'll go back to our title abstract search strategy. Okay. I'll share the link. Now you can see with weight change, we got only 8,800 results. But with weight, we are getting 947,000 results. Why is it so? Because it may just talk about, say, the baseline weight of patients. It may not talk about weight change or weight gain or weight loss. So again, if we use this strategy, we might miss many articles. Sorry, we will get too many articles and we will not be able to complete our screening. Therefore, we can't use this. What we will instead do is, what are the common synonyms for weight change? We can take it as weight change, weight gain, weight loss. So these are the three ways in which articles usually report weight change. So we will use this instead. Because as you can see that in weight change we got 8,000, but in these three we are getting 174,000. So there were many articles which we were potentially missing when we restricted ourselves to weight change. The articles which would have reported as weight loss, we were missing out on them. So we have to use this strategy.
How to combine these searches?
Yes. So this was our research question. In this, our population was diabetes. Our intervention was metformin and outcome was weight change. So population is diabetes. This is the 10th search strategy, 10th search string, diabetes. We will add this here. Then we will use the Boolean operator and. Now we will say the intervention was metformin. Metformin, we don't need to adjust for synonyms because articles do not address it by the chemical name. They always address it by the metformin word. They don't even use the brand name for it. So synonyms are not needed here. So we have the population, diabetes, we have the intervention, metformin, and what was our exposure? What was our outcome? Our outcome is weight change or weight gain or weight loss. This will come at number 11. Now if we add this, we have gotten 1784 articles. Now this is a big number for a usual SRMA, but this strategy will work. I will tell you the reason why. In this specific example, effect of metformin on weight gain in diabetes, metformin has been used for decades. And there have already many systematic review meta-analysis accounting for this. So this was an unneeded research question that I just came up with. there are so many articles that there's no use of repeating a meta-analysis on this. Therefore, that is why we have gotten so many results. If I would have searched some such topic where there are not many meta-analysis done, there are not many original studies, then I wouldn't have got such a big number. For example, we will repeat the same thing with a different drug instead of metformin. Say if I say diabetes as my population, semaglutide as my intervention, and weight change or weight gain or weight loss as my outcome. And now if I combine this, we have combined number 10, that is diabetes, with number 13, semaglutide, with number 11, that are the weight parameters. Now you can see we have gotten just 211. Instead of metformin where we got 1784, we got only 211 with semaglutide. This is a feasible number. We can screen these many articles. Therefore, devising a proper search strategy is very important. If you go very specific with your search strategy, then you may miss many studies and your meta-analysis may not be very meaningful. And if you are very sensitive with your search strategy, then you may not be able to complete your manuscript. So we have to maintain a fine balance between the two. And research has to be reproducible. So in a systematic review, what we have to do is that we have to report what was the exact search strategy that we have used, so that the reviewers or the readers can see whether our search strategy itself was flawed and therefore our study itself was flawed or not. They can check that. That is why we have to report this. It's not that we can just search some articles and combine them using some meta-analysis tools and report. If you do that, your article won't be considered credible. You have to actually give details of what search strategy you had used. That is why documenting this is very important. So we will document this. Now you might take a screenshot of it,
No.
but that is not the preferable method.
Dr. Akib, suppose the word is chronic kidney disease. So how we
Okay.
come to the truncation, what word we have to use and use the truncation part?
Yes, chronic kidney disease is like, that's a 3-word phrase. So in that, truncation is not needed, because again, even if we see the individual words like kidney is written as kidney. It's not written as kidnal or something. If you have to change
Renal
it,
somewhere.
so it becomes renal. So we can do a chronic kidney disease or
Somewhere it is
chronic renal
the
failure.
abbreviation form CKD, somewhere
CKD.
chronic kidney disease.
So that is what they
How-
do. Yes, sir. Now, sir, I will come back to your question in some time. I will just show how to document this search strategy, and then I will come to your question. So how we write this is that if I open MS Word now, I guess that will not get shared. It's just sharing my browser. So I will use Google Docs. So we document this as we copy this part and write it as hash one. We write our search strategy and then we copy the number of results. It is 752, 985. 752, 985. This thing has to be made in a table format. Like you can do the formatting. I'm just trying to show you the details that we have to write. We write it like this, and then on top we write results from databases on this specific date. Then we specify the database. The database that we were using here was PubMed. So in PubMed, we searched first for this thing and we got this. Next, we searched for we searched for semaglutide and we got 938 results. You can see 938 results. Next, we searched for the weight terms. We will write it as number 3. Weight terms. And the number of results is 174, 172. These are the number of results. And what we did next was that we combined the 3 search strategies. So and we got 211 results. This is what we have to document. We can do it in a Excel and in a tabular form and then export it to Word, or in Word itself we can make a table and make it more presentable. I wrote this now just for showing how to build it. I guess we will even share our template that we use. Like after writing several manuscripts, then we zeroed down on one template that we felt made it much more presentable. So we can share that template in the group. We can share a template. I wrote this down here just to show you how we build it. We write the date on which we searched. We specify the specific database, and then we tell the search strings and the respective number of results. Similarly, I would write for, say, Scopus, and then I would write number 1, and then I would write the search strategy here, and then I would write the number of results here. This is how we would continue building our search strategy. And the search strategy has to be documented. This is usually attached in the appendix of the article of the manuscript. But it's not that just because it is in the appendix, people don't see. I remember that in my first systematic review, the reviewers even commented on this, and they asked us to make some changes. So we made those changes in the review, and later it got accepted. So don't think that this is just a formality and it will remain embedded somewhere in the appendix or supplementary. No one is going to see. Reviewers do check this also, because this is an initial step of SRMA. So mistakes here can affect the whole results. Coming to someone had asked about CKD. How will we devise a search strategy where the population is chronic kidney disease? This can be done in 2 ways. One way is that you can think of the different ways people write chronic kidney disease. Some may write it as chronic renal failure, or some may write it as CKD, some may write it as CRF. There are many synonyms. We may know this from experience by reading previous articles, or we may think. Another way, which I feel is the more, along with thinking on your own, you can use this method too. We will go to PubMed. We will search for chronic kidney disease. We will restrict our search to meta-analysis. Here on article type, you can see there is a field for meta-analysis. So what we are doing is that we are just searching for previous meta-analysis on chronic kidney disease. I will open one article. I will go to the full text and I will see what search strategy they had used. So we can even take ideas from them, because research is not doing everything on your own. You have to build up on what has already been done previously to save everyone's time. when you open a meta-analysis, the full text may be very long. You have to go to the method section, search strategy. Here you can see they have written the search strategy was kidney disease or kidney failure or kidney insufficiency. I will zoom it so that people can see clearly. Kidney disease or kidney failure or kidney insufficiency or kidney function or kidney dysfunction or renal disease or renal failure or renal insufficiency or renal function or renal dysfunction. So they came up with 10 different terms. We could not think. We could only think of 2 or 4: disease, failure, kidney, renal. So they have come up with 10 terms. So here we got an idea from them. So we can use previous published articles for our to get an idea too. So is it clear till here for everyone? If you have any doubt till here, you can ask, and if it is okay, then we will proceed with the next part.
May I ask a question, sir?
Yes, you.
Sir, suppose in a study, if we get the very limited number of studies, then in that case, what will go?
Uh, like uh, like when you searched, you got very limited number of results, right?
Yes, suppose in when some 10, 20 or 15 or something, some units also, then
This
how can we go for?
there's no issue. It can be true. I like if I search for say,
Sir, actually, my research question is
huh,
what is the coverage of HPV vaccination among LGBT?
acha. Okay. So here, we will write it down. Coverage of HPV vaccine in LGBT. Okay. So we have the population of LGBTQ
Yes,
and there is no exposure or comparator. We are just assessing the prevalence.
yes,
So our outcome is
coverage of HPV vaccination.
now one reason why you're getting an obvious reason for getting less results is that there may be very few original studies commenting on this,
Yes, sir.
because anyways many people, even if they're LGBTQ, they don't report themselves like that. So in articles they may just mention male female, they may not specify this group. Or another reason is that LGBTQ has many synonyms. Someone may so like if someone might use the word transgender, like different words may have, like they may be slightly different in their meanings, but overall different people may use different terms for this. So you have to ensure that you properly use the synonyms for LGBTQ.
Sir, another term is the sexual minority group.
Okay.
So can we combine this?
Yes, you can. That is what I'm saying. You can, whatever terms you can think of, you can combine them. And like we saw in the previous example, we will go to PubMed. Again, same thing. We will search for articles on LGBTQ. We will search for previously done meta-analysis, or we can even search simply for systematic review. We will look for the free ones. So we got a free, a freely available meta-analysis on LGBTQ plus. We will go to the article. We will go to the method section. We'll go to the search strategy, and here you can see they have used such a big, such a wide search strategy for the population. Yeah. So here you can see they've used transgender, transsexual, gender non-conforming. They have used, I guess, more than 20 different terms to describe the population. So this may be a reason why they may have gotten many results. They even used the minority groups or gender minority that you were saying. So you can use your experience with the topic, like you may have read many articles on the topic, you can use that to come up with search terms. And along with that, you can also search previous literature. This I feel is the most time-saving method. Like think a bit on your own and then look for previous articles. You
Okay,
can
sir.
easily get ideas.
Okay, sir. Thank you, sir.
Sir, I want to one ask a query that
Yes.
there are some of the pre-publication articles published on some of the handles like MedRxiv, like
Ye- Yes.
so can we use that articles in our systematic review and meta-analysis?
Yes, we can use. If you remember our, I will show you. There's our workshop group. We
But
registered.
but peer review is not happen, sir. Can we use that?
We can use it. Like even in the protocol which we registered yesterday. Okay, it will not open here, but even there we mentioned that we will use 7 different databases and preprint servers. Now about a concern regarding peer review, I feel Pari sir can answer that better. Uh, Sir is here in the meeting, but his internet connection is quite unstable in Andaman. Even when we are talking to him, so there sometimes his voice drops. So probably his connection might be a bit unstable now. Actually, we do use many studies, like studies do use preprint server studies also for SRMA. Now, I know the concern that you're talking about. I feel like sir can answer that better as to why they still use it in spite of a lack of peer review. You can ask this in the group after the session. Sir can answer it better because it's related to the ethics of an SRMA. But it is used commonly. I'm sure about this, especially if, like in monkeypox, there are very few articles. So I remember that in my systematic review, when I started including the preprint articles, the number of eligible articles increased a lot. Like studies had just started been reporting, so including preprint helped in that we could comment on many more studies. In places, in topics where you already have dozens of studies, probably you can avoid preprint. But when there are very few studies, we try including it.
How do we access the preprint servers?
It's they are freely accessible. Like there's one which search said MedArchive and BioArchive, or I guess there can be searched together. I will see. Okay, I will show you. You can search MEDRXIV in Google. You will get the first result, MedArchive. That is what we got here. Here you can go to advanced search. Again, the search is not this thing is not as good as PubMed, but you can explore this yourself. Yeah, this is the search builder. One thing that I would like to touch upon is that you can choose which articles to include. You can click here and you can include both these preprint servers, BioArchive and MedArchive. So now articles in both these preprint servers will be searched here. Similarly, there is something called SSRN, if I remember correctly. Yeah, this is also preprint server. Here also we can click on search, say okay, I searched as a niche topic that no result came. Here like you can search by title only, title abstract, or by full text. You can see I found 6 articles here. When I searched for semaglutide and weight, I found 6 articles. And you can see one thing. There is a meta-analysis in preprint. So, I mean, if you are planning a study, you can even like this is posted long back, June 2021. I guess by now they must have even published it. But if you're in the planning stage of a study, you can even check these preprint servers. If there is someone has already completed meta-analysis, then probably starting that article from scratch for you is not worth it. But this is an old one, so we can definitely repeat. But just saying. So these are some of the preprint servers. Med archive, bioarchive, SSRN. There's also something called CHIE, SSRN. There are several such preprint servers. But Med archive is, I guess, the most common one. I hope it is clear till here.
But sir, should we include, it is mandatory to include the preprint
No, it's
articles?
not. So it's
Okay.
okay. So it's not at all mandatory, but it's like it depends upon what you pre-specify in your protocol. You have to say in your protocol whether you will include preprints articles or not. One thing you can do is that if you feel you are going to get many peer-reviewed published articles addressing your research question, then you can choose to avoid preprint articles.
Okay, sir. Thank you.
That might add value. Okay, now we will
So
move
I
to the
have one
yes,
doubt, sir.
yes.
My topic cancer, frailty, and clinical outcome. When I'm looking at it on the advanced search, I'm getting initially I was getting 15 articles, but many of them are not correlating with the things that I wanted to do it. So if I get less number of articles, then with that, can we do it, or how is it?
Like for meta-analysis, they say कि if you're doing an meta-analysis of observational studies or not RCTs, at least 4 you should include. They say so. I mean, it's just that like if we are not getting enough studies, then we can do a systematic review, but not a meta-analysis. And this is, I feel, a limitation कि in SRMA, we should not get very creative while forming the research question because we might have a very good idea, but if someone has not worked on it before, so you will not get results. Therefore, SRMA is more about compiling the available evidence than about generating. I mean, we do generate evidence, but it's not like we generate something out of the box. That is done rarely. What we're doing is compiling. So we should not sit and think, ki, Acha, what effect this may have on that? Let's do an SRM on it. If we sit and hypothesize, that is good for original research. For SRMA, we should focus on what has been reported already. So we should take that approach. Ki what has been reported, we will combine that. So many times it happens that what we are searching for, there are not many studies. Now, as per the
Mesh
yes,
terms will help.
yes, so mesh terms help. We can include mesh terms also here. The only point is that like we are going to include say Embase, Web of Science, and also converting your PubMed mesh terms into Embase is a bit difficult. You need access to Embase. Similarly, for Web of Science, for Embase, I guess it uses MG instead of mesh. Even for Web of Science, if you have to use the equivalent of mesh terms here, again, you need access for translating. This thing can be easily translated from PubMed to Scopus. Even if you don't have access to Scopus, I will show you a template using which you can translate this search strategy into Scopus. Because if you just copy paste this into Scopus, you will not get result.
So can you elaborate on the mesh term?
Yes.
What is mesh term, sir?
Okay. Okay, I will come to that the last because this meeting sometimes it expires at 9:30 na? So I will just write it here that I have to cover it. I'll come to that last. Okay. Sir, I will cover mesh at last. I will first continue with the flow, and then we'll come to mesh. So we are using several databases, like in the draft protocol or the draft plan as shared by Parisar in the group. We are accessing 7 databases, I guess. So PubMed, Scopus, Embase, Web of Science, EBSCO for the thesis thing, and Cochrane. And I don't remember which one more. PsycInfo, I guess. I'm not sure. So there's another database. Probably PsycInfo. Let's check it. So we have to, if we search this in Scopus, it won't show results. For example, I will show an example. I will try searching it in Scopus. And to share for this. If I search on Scopus, here in Scopus, if I go to advanced document search, and now if I copy what we had previously, that is diabit star title slash abstract, if I copy it here, it shows 12,147 results. But you can see that the articles, the first one itself is on osteoimmunological effects of macrophages. You can see that none of these articles even have diabetes in the title. All the first 10 articles, none of them had diabetes even in the title. So the main issue is that if we just copy paste the PubMed search strategy into Scopus or other databases, it may not work properly. So what we instead do is that we convert this into the syntax that is required for Scopus. For Scopus, I can do it manually because I have access to Scopus, but I don't have access to any other database. So say I did this like this, then I clicked on search. I went to advanced. Here I got, achha, this is how I should have instead searched. PubMed searches it as type star slash square bracket title slash abstract square bracket. But Scopus instead wants us to input it as title hyphen apps hyphen key circular bracket with star circular bracket. So therefore, different databases have different syntaxes required. And usually we only have access to limited databases. For example, Scopus is the only premium database that I have access to. I don't have access to Embase or Web of Science or EBSCO. So we can use a template to translate our search strategy. I will go back to our Safari. So what we have to do is that we have to translate this whole search strategy into the syntax required by these specific databases. Am I clear?
How to do that translation?
Yes. Yes, I'm showing it. So I had made the draft.
So does Scopus suggest how to search like you did? I missed the last part.
In Scopus, you can manually like in PubMed, we did this part manually. We selected title slash abstract over here. We wrote EIA BET star over here, and then we added it and searched it. You have to repeat it like this in Scopus. And if you do not have access to Scopus, then you cannot do it. So that is why we can instead use a template to just simply translate our PubMed or Medline search strategy into other search strategies. Uh, so this is what I done for one of my studies. So for example, if you use PubMed as the base, you can see that our first term is I will zoom it so that it's clearer. Our first term was within double quotation marks respiratory infection and then title slash abstract. This same term came as double quotation mark respiratory infection star and then TI comma AB comma KW in Cochrane. So this is how we have to write it in Cochrane. I'll show you. Permit here. Here. So for PubMed, what I wrote like this will become for Cochrane. I did not do this beforehand purpose. I want you to see how we access this template to be able to edit it later for your use. For Cochrane, this is the part.
Just a minute, Akib.
Yes.
I request all the participants to mute themselves. I think Dr. Ankit, someone's background noise is disturbing. Thank you. Dr. Ankit,
So
please mute yourself. Or Akib, can you mute him?
yes, sir. I've just muted Ankit, sir. I guess you. Yeah. So this is the search strategy in Cochrane. We after this respiratory infection thing, we write TI for title, AB for abstract, and KW for keyword. So I'll just copy it.
So, sir, how we will know about the syntax used in different data?
Yes, sir. I'm coming to it. So this is a template, sir. That is why I was saying we have this template. You can see in PubMed, if I had to write respiratory infection like this, I had to write it like this in Cochrane. Now, say if I have to write semaglutide this way in PubMed, I have to write semaglutide like this in Cochrane. The place where there was respiratory infection, I've just replaced it by semaglutide. And since it's a single word, there was no need of double quotation mark. I hope, is this part clear for everyone? Or we can repeat it once again. How we converted semaglutide from PubMed to Cochrane, translated.
Star also
Yes,
with
sir.
Okay, we will.
Like how do we which all databases we can have access?
And that actually depends upon our institute. For here, I mean here, Parisar has access to all these 7 databases that we are talking about here. So what you can do is that you have to develop this, like we documented our search strategy for PubMed. Similarly, we have to document our proposed search strategy for the different databases. We'll just leave the column of for numbers blank. Other things we will document it over here. And if we have some database, we will search. Otherwise, we will document and forward it to Parisar or someone who has access to databases. They will just search and note these numbers down and export the results as required and send it to us. So we are going to need the help of someone who we will need to involve someone who has access to these databases. Otherwise, normally some people, what they do is that they just use 3 or 4 databases for systematic reviews. That can also be done. But now here, since we have the facility, since Parisar is allowing us to do it, it's always better to use more databases. It increases the credibility.
Sir, you have the format for all the databases. So that's why you only copy and paste it and just change the search word. But
Exactly, sir. Yeah.
but it is not for like people like us who don't have
So,
any.
so we will share this template with you. That is why I made this file specifically for today's session. Actually, we actually just copied from the different databases. This is what we had done for a previous article. For that it took us time, but now that we had prepared this database, this template for our previous article, now it doesn't take us more time because we just have to replace this thing. So we will provide you with this template. That is what I'm just trying to show you ki how we will use this template to get our work done.
Sir, suppose we don't have the access, then with these syntax, can we search in those databases if we don't have the access?
No, we can't search, but actually the thing is that we can make it easy for the person to whom we are sending. The point is that if we just send this much to the person who has access, he will have to manually type all these words in that Scopus thing, and then like it will take a lot of time for him. So, and if he is doing that for 20, 30 different manuscripts, then then it may not be feasible for him. So what we are doing is that we are instead converting it, the syntax for each database. Now the person just has to copy this. He has to just copy this, paste it, see the number of results, document it, again copy and paste this, see the number of results and document it. So it saves a lot of time for the other person, especially if they're working on many manuscripts. This is the main reason behind preparing this. We can try this translation for another. We can for another example. Suppose we are taking this diabetes title abstract. This is how we had searched for diabetes in PubMed. So what we are going to do in Cochrane, we are going to, you can simply copy this, paste. Instead of this respiratory infection part, instead of respiratory infection, I will write diabet. And since it's a single word, not a double, not a two-word phrase, we will remove the double quotation mark. This is not needed. So now this is the search strategy for Cochrane for this thing.
What is the use of star in Cochrane in respiratory infection?
Sorry, the thing was that if someone writes it as respiratory infections,
Okay.
that is why. So I did not want to like put two words, so I just put it as infection. Now we will see how they do it in the 7 databases we have done for PubMed and Cochrane. Next for EBSCO, we can again see this is how we had written respiratory infection. TX space respiratory infection inside double quotation mark.
Sir, will you have to remember all this syntax?
No, you can just see and do this. No, we will provide you with a template. So you have to just. That is why I'm trying to do it in along with you so that we can see an example of how to use this template. So you can just copy paste from here and see. There's no need to remember. Now for embed. Yes, sir.
Dr. Akib, am I audible?
Yes, sir.
Okay, dear friends, those who are attending this session, you see, conducting one meta-analysis, it takes more than 4 months.
Sorry, your voice is breaking.
Template. My voice is because I am in an island and the very low network, so therefore voice is breaking. So my question is, so we have standardize all these things to help you. So that's why you are able to produce a manuscript in 1 month or 2 months of time. So that is the key thing that we want to deliver. Okay, Dr. Akib, please continue.
Okay, sir. So as I was telling that making this actually takes time. So now that we have actually made it, when we are repeating it, it takes less time. So that is why we are sharing this template with you also, so that you can focus more on the research question and the discussion part and not on this. Because this is an important part, it's an important formality, but it takes a lot of time. So for Embase, this is what we had. Now you can see, this may look very similar to Cochrane, but you can see that Embase actually only has a single quotation mark, whereas Cochrane had a double quotation mark. And Cochrane kept the search term in circular brackets, whereas Embase did not do it. So there are subtle differences between the different databases. Now we will look for ProQuest. In ProQuest, you can see they are using, this is the part for respiratory infection. TI, AB and bracket, double quotation mark, respiratory infection. Now we have Scopus left. In Scopus, as we had earlier seen in the Scopus website, they use this title ABS key part. So this is our search term in Scopus. I'm keeping them all at one place so that you can see, and then we will practice an example. Yeah, we have time, we can practice an example now itself. For Web of Science, this is the search term. Do you find anything different in Web of Science than other such databases?
For Cochrane, where do we search? Cochrane database or advanced search?
In advanced search, we can do.
Hello?
In Cochrane. Yes, yes, ma'am. In Cochrane, you can do it in advanced search.
In
It's easy.
Cochrane, where do we search, sir? In the advanced search?
I will see.
Can't hear.
Can you see the screen, ma'am? Yes. Am I audible, ma'am? You were saying you can't hear.
Yes.
Okay. Okay. So we have searched Cochrane. Here you can see there's a button for advanced search. So we can actually go there and copy our search strategy to Cochrane. No, so you can do it here. It's actually quite. You can either do it manually over here or in Search Manager. In Search Manager, you can type that exact code part. This is a bit less user-friendly than other databases. So we did till, so we have 7? So we have the 7 databases here with us. As for the preprint servers, even if we are including writing the search strategy for them is not so important, because in them, like many of them, in some of them, we don't even have this option of searching by title or abstract and that thing. So you can, for preprint servers, we need not document. Actually, some articles, they only document their search strategy for PubMed or Medline. They don't even document for the other databases. We are doing it as a way to be more transparent about our work, so that people can see and comment on it. Now let's try an example. Suppose,
Can you repeat the previous part you told us?
Uh, which part, sir? Actually, some SRMA, the published SRMA also, they report their search strategy only for PubMed. That is, they report only this part from here to here. They don't even, though they have searched in other databases, they don't report their search strategy for other databases. And at the same time, there are many meta-analyses which also report their search strategy for other databases. You can find both types of meta-analysis. Therefore, uh, I mean, it's always better because when you report for all the databases, you are being more transparent. What was your process? How many results you got for each? Was there any mistake in your process? You are letting the reviewers see and check everything.
Yeah.
So it is preferred if you do for all. And it's like it's something that doesn't take much of an effort if you get used to it. And it can add credibility, so why not do it?
Okay, thank you.
You're welcome. Yeah, so we will practice for, say, we'll choose a single word for simplicity, metformin. Okay. Suppose this is the search, this is our search term in PubMed. Now, how will we write this in Cochrane? Can you write in the text box of WebEx and show me how we are going to write this thing in Cochrane? Now, Dr. Shalini Singh, you have written it correctly. Sumit sir, I would just like to add one thing. In Cochrane, we actually we need not give the quotation marks over here because for metformin, since metformin is a single word, it's not a two-word phrase. So this quotation, double quotation mark or single quotation mark is not required. For example, for Cochrane, if you're writing it, we will simply write it as we will remove this double quotation mark because it's not needed. It's a single word. We will also remove the truncation because we'll remove this truncation because we are not using it here. We'll remove this. And we'll just write metformin. This is how we will write it in Cochrane. There's no need of truncation or double quotation marks over here. Similarly for EBSCO, can you try writing this for EBSCO? How are we going to write, how are we going to translate this search term into EBSCO? Yes. So here, when we are translating this, here again, we will replace respiratory infection by metformin. And since it's a single word, we don't need these double quotation marks.
Excuse me, sir, how to manage the Boolean operators in the other databases, means apart from PubMed?
It's the and or is same in other databases also. As you can see, even in Web of Science, we used or for the different synonyms within population, and when we had to combine the three search strings, we used and. So this or and thing is common across all databases. At least the ones which we are using, we have seen it, we have checked manually that it is common. You can see or and works everywhere. There may be some other Boolean operators that may not work with other things, but for or and I'm sure that it works with all 7.
Hash will also work when we combine the results.
Yes, sir. For Embase, I guess it's just one, not hash. Actually, this I also don't remember because one after I have made this, I just keep on using the template. And this uses hash, this uses hash. For ProQuest, okay. For ProQuest, we just write 1 and 2 and 3. We do not need hash. I guess that even if you write hash, it shouldn't be a problem. But I had tried with this and this worked. 1 and 2 and 3 worked with ProQuest. And even with EBSCO. So ProQuest and EBSCO, we do not need to specify hash. In some databases, like even if you write #1 or just 1, it works either ways. It depends, but this thing works. I'm sure about this. What we have what we have compiled over here. There may be alternative ways also. Can you write for Embase the translation of this string to Embase? I know that it may sound very obvious and simple to many, but it's just that I want all of you to practice this once together before you actually do it for your manuscript. When all of us practice it together, it may help. And if we are making some mistake, then we can discuss on that.
Zoom a little bit, please.
Okay, sir. And I will use the font size. Is it clear now, sir?
Yes, sir.
Okay. Yes, for Embase, most of you have written it correctly. I would just like to add one thing again. I guess someone I saw who wrote it with quotation mark. It's okay. The thing is just that we don't need these quotation marks here. Most people have written it correctly. Similarly, for you can try doing for ProQuest also. I will just take 3 or 4 minutes. We will complete these 3 things. Now, if I feel I have copied this wrongly from the template, this bracket should not be there, I guess. We will again check the template. ProQuest.
Assalamu alaikum.
In ProQuest.
कैसे?
Yes.
मम्मी अच्छी बज्जी वाली है मेरी मीटिंग की तो मम्मी
If you're talking in a home, you can mute. Yeah. This bracket that you see over here for ProQuest, the first bracket, this is actually not for this term. This is for closing the entire thing. This bracket that is closed over here had been opened here. Therefore, when we are doing it for a single word, we will not copy from here. We will instead copy from here. So this would be the ProQuest corresponding search term. So it should be like this. Yes, like people are doing it now. This is how we have to do.
Capital words, do they make difference?
I'm not sure about this. I have not read about this specifically. I guess we can try doing with capital and small and see whether the number of results changes or not. I guess that will be the best way to check this. The same word we can type in PubMed in small and in capital, and we can see if we get the same number of results or not. Also, we can check now itself. Metformin, we got 28,393 results without caps. If we keep it as caps, we are still getting the same number of results. Let's try something like even when I made a very strange combination like this, the number of results remain the same. So we can sort of conclude that the uppercase or lowercase status of these alphabets do not matter, at least in PubMed. You can try translating this to Scopus, this search term. Yes, now everyone is people are doing it quite fast and they're doing it correctly. Similarly, for Web of Science, we can simply write it as metformin. So this is how we can do it for the 7 databases. Now I will show you the template again. Here you can see I did this respiratory infection or respiratory tract infection or streptococcal sore throat and so on. This was my population, which was in the first row. In the second row, I had different things for antibiotics and antimicrobials. And in the third one, I had different words for behavior and expectations. And at last, I combined number 1 and number 2 and number 3. This is how we are going to do for all the 3 databases, for all the 7 databases. This is something which initially it may take time, but as you experiment with this and keep on working and you send it to someone and see whether your search strategy actually worked or there was some mistake, then with time you can easily improve in this.
Can you
This
repeat?
is okay, sir. Okay, I will repeat it with an example for a database. We'll do it here, sir. In PubMed, we had this search strategy. Now, how are we going to emulate this in Scopus? So we will first take the first line. In first line, we had to write it as diabetes star title abstract. Now we will see how we should write it in Scopus. I will copy this here. So if PubMed is like this, then Scopus should be title, apps, key, and diabit asterisk. Is this clear to everyone how we translated for Scopus? I copied the PubMed database, the PubMed search term here to my rough sheet. I changed it to the corresponding search term in Scopus. Now this thing, we are just going to take it there. This is our fair sheet. Now, what are we going to write here? This we are going to leave it blank for the person who is going to check it. They are going to give us the results. Similarly, for the second search string, we are going to see that we had semaglutide work in title / abstract. So for Scopus, we are going to write it as semaglutide. This is our Scopus search term. We are going to copy it and paste it over here. and leave this empty for the person to update. Now this is a longer path. Here in this one search string, we have 3 different search terms. We are going to copy this to here. And now we will see that how we are going to do. So first we have weight change. So we are going to add it as weight change or title apps key weight gain or title apps key weight loss. So this is how we are going to, so this is our translation for this search term. Translation to Scopus was in this manner. We're going to copy it and paste it over here. Now our final search string is just a combination of the 3. We will see how they combine in Scopus. In Scopus also they use the same thing, hash. So so now we have our search strategy translated into Scopus 2. We just have to
So
send
what
it.
about double brackets?
So the quotation marks.
No, double brackets we have in search strategy 3 in PubMed. Here we don't have any brackets in Scopus.
So that is because we did not use the template. We will see in template how to do it in Scopus. So in Scopus, if you see, we just need double brackets at the start and at the last. So one extra pair of brackets is needed for the whole strategy. So we will put the same thing here also. One thing at the start and one circular bracket at the end. So we have this now prepared. We have to just send it to the person who has access to these databases. He will write down the number of results for specific search strings, and he will export and he can export the results and give it to us for screening.
So double bracket close in PubMed search 3 should also come after weight loss bracket, no? Not
And
after.
this is, but the thing is that we did not do it manually. It was generated by PubMed on its own. So probably it feels like, I mean, not feels, but this is the way PubMed works, because even if we change it, it won't make a difference. I'll show you.
Okay.
If you're searching like this, we're getting 174, 172. Now, if we instead remove this bracket to the end, we are still getting the same number of results in spite of the change of the location of the bracket. So does that mean that the location of the bracket is not important? No, it does not mean at all. It just means that when we are using OR as a Boolean operator, then the location of bracket doesn't matter much. But if we would use AND, this matters a lot. We will see this with an example. Because if we have to use AND, then we should not use it in the wrong way. Suppose it makes difference in certain cases. Here, suppose I am searching this and I'm getting 106 results. Again, now I'm removing this bracket and placing it here. It is same. Now, instead of this, if I if there was certain, like if you do permutation combination, you'll find in a certain case it does make a difference, this bracket thing. if we're keeping this within or, you see, simply changing the location of the brackets caused the results to decrease a lot. Even when the search terms and the Boolean operators were at the same location, we saw a change in the results. Why is it? Because here we were seeing first and second, this was one part, and then it was uh, seeing whether 3 is also present or not. So it was 1 and 2 or 3. But here what we're instead seeing is that 2 or 3 comes within the one thing. I will show you with a better example for more clarity. 1, 2, 3 on each hand. Okay. 1 and 2 or 3. Similarly, you can see the difference over here. When I searched 1 and 2 or 3, I found one result. But when I searched 1 and 2 or 3, it showed 0 results, even though the Boolean operators and the search strings are same. So when we are using different types of Boolean operators, the location of the bracket may be important. It depends upon the context. If everything is AND or if everything is OR, then it doesn't matter. But if we are using a combination of these two, it matters. So like this, we can, like we had translated this single search terms into the respective databases. We did for Cochrane, EBSCO, Embase, ProQuest, Scopus, and Web of Science. Similarly, we can translate our whole search strategy into the respective databases and prepare this file. Now there was one doubt, I guess, on mesh. So mesh. Someone had asked whether we should include mesh or not. Yes, according to Prisma guidelines, it's preferred. We should include mesh in our search terms also. So mesh is Medline's method of indexing the search results. What happens is that some article may use the word, like if you have synonyms, like in the case of CKD, some article may use the word chronic kidney disease. Some article may use the word chronic renal failure. So if we search for one of the two terms, we will miss other articles. So what PubMed instead does is that it indexes individual articles to certain search terms. So even those articles which are on chronic renal failure and which do not mention CKD anywhere, even those will be searchable if we type CKD using mesh. So what it means is that suppose if I just write in all fields, if I write chronic kidney disease, you will see how this actually searches. It doesn't search it as chronic kidney disease. It searches it as advanced. What actually runs in the PubMed software behind this thing is this. It searches for renal insufficiency chronic as a mesh term. So therefore, all articles on chronic renal insufficiency are included. Whether you search for chronic kidney disease or chronic renal failure or some other synonym, these things, suppose some article only writes chronic renal failure, still it will come in this search. Why? Because it is addressed under this mesh term. So it is a way of harmonizing the results. But one drawback is that this mesh facility is not available for all articles. Especially for the new articles, they are often not mapped to the mesh index. So new articles may not come under this. And coming to our search strategy, it is advisable to include mesh terms also there. So here we had written diabetes star title abstract, we should include the mesh also. So our mesh word is, if you search for diabetes, you will find the mesh word. You can see here that the mesh word for diabetes, for the one that we are looking for, is diabetes mellitus mesh terms. So we will copy this, we will keep it here, and along with this we will add whatever we wanted to add, that is diabetes star. We will combine this using the Boolean operator OR, and we will add it to history, and we will use this search term. We can also use this search term for our work. So instead of diabetes star, we are going to instead use this diabetes mellitus mesh terms or diabetes star title abstract, and the number of results also has gotten increased to 800,000 something, I guess. Okay, 813,841. Similarly, for semaglutide also we can search for the mesh term over here. If you look here, all fields semaglutide mesh term here. In semaglutide, there is no corresponding mesh term, so it's not needed. For weight change or weight gain or weight loss, we will see what are the associated mesh terms. This body weight changes is a important mesh term. This is a broad mesh term that includes weight gain and weight loss also. So we can just use this mesh, body weight changes, in combination with what we were using. So these three things will remain, and we will add this. So we are going to again update this number, and then we will update this number. So where we are getting an appropriate mesh term, we can add those mesh terms also to our search strategy. Now there's a reason why I did not mention this earlier. It's that these mesh terms cannot be translated into the other databases very easily. For this, you actually need to know whether Scopus uses the same term, that is body weight changes, for its indexing thing. Like mesh is the word which is used for PubMed. Embase uses M3, something like EMTREE is equal to mesh for them. Similarly, for Scopus also there is something, I guess. So translating these mesh terms into the mesh terms of different databases is not easy. So while searching in Scopus, you can just simply keep these terms. You need not you can probably leave this part and this part. The others can be translated. And for the PubMed, which is the first strategy that we're going to report in our supplementary, and which we might even address in the main text of our manuscript. So for that, we should include the mesh terms also.
Mesh term would not be same for Scopus and PubMed.
No, sir, it is not same. Like it may or may not be same, because this is something that has actually been manually. This like the thing which librarians use to sort different articles. That is the origin. So it is like so this changes from database to database. The mesh equivalent that we have in Embase may not, like diabetes mellitus is a common thing, so it may be same there. But for body weight changes, they might actually have just weight changes or some other term. The way to check this is that you have to actually go into Scopus and search the word and see what is the indexing word that they have used. If we do not have access to the database, we cannot do that. So we can skip this in translation. But if we have access to the database, then we can include this part also.
Can you give example for Scopus for mesh?
Scopus mesh, sir, I'm also not, we can try, okay, I will open Scopus. Okay, sir. So the thing with Scopus is that I just checked. Okay, I will share my Google Chrome because Scopus doesn't work for me in Safari. Share. Yeah, I tried searching over here. I did not find over here. Then I saw that they have a keywords thing. Now, if I check this guide, and they said, oh, this one I guess I said. Scopus does not have mesh terms or other subject headings on which to search. It instead uses the keywords part. So this mesh terms concept is not there in Scopus, so that is a good thing for us. We do not need to worry about that. But for Embase, we have this Embase mesh terms. You can see this. M-tree is used for full text indexing of all journal articles in Embase, while mesh is used to index articles for Medline and also for PubMed. Now you can. Now I do not have access to Embase, therefore I cannot show you a live example. But here they did give example somewhere. I'm not sure if it was this article. So this is often same. Like you can see adalimumab, the M-tree name and mesh name are same, but you can see an exception here. While M-tree names is at Embase names the index search term as etanercept, the mesh names it as TNFR FC fusion protein. Similarly, you can see that for this drug combination, or a simple example is glargine. Mesh simply uses the word glargine. M-tree uses the word insulin glargine. So there are some changes of differences between the two, and since it's not an automated process, we cannot predict this. If we know PubMed thing, we can't predict what is the M-tree thing, the M-tree search term. So we can instead leave it empty. So I will go back to Safari. And that is why while translating, you can avoid this mesh terms part. If you have access to Embase, you can manually go check this. Otherwise, you can just translate the other parts like we did for Scopus. Is it clear till here? If you have any doubts, you can ask. The session is like officially over. This is what we had planned to convey today. If you have any doubts, you can ask. We will share this template with you. This is the file
And
that
sir,
I've created.
please also share the recording because sometimes the voice was breaking.
Okay, I will check whether it was being recorded. Yeah, it was being recorded. Towards the early part of the session, we got that thing, na, okay, your session is being recorded. So yeah, it has been recorded. I guess it is being we are being helped by the telemedicine department of PGI Chandigarh for this. So it may not be comfortable if sir goes and asks them every day for the recordings. I guess at the last or when he feels comfortable, he will ask them to share the recordings and share it in the group.
Sir, I have a question.
Yes.
So, for the search strategy, can we search like gray literature and conference proceedings and all these things? One question. So, second point was, like Dr. Padi had asked, like we take an article and we can we can see if from the references of that article
Yes.
can get more articles. So, this thing cannot be, I think, included in as a search strategy, or can we put it like if we get one or two extra articles from in this way?
Okay. So we can definitely include them in our systematic review. But this file that we had, this file that we were creating, it was just to document our search strategy. It doesn't document our search results, the screening thing. I will show you what I mean to say. If we check the Prisma flowchart, this will actually be covered in the later sessions, not just for better explanation. We will look at it in brief. Prisma has an updated thing. Look, if you go to the Prisma website, in the flow diagram, you will see we have one flow diagram for search of databases and registers only, and another flow diagram for databases, registers, and other sources. We will open this one. I hope it opens in Safari itself. No, it has gotten downloaded. Okay, I will try to share the full desktop. Share full screen share. So if we look at it carefully, we can see that this is the main part. We will write here that we found this many results from databases like PubMed. We will say we found this many from Scopus and so on. Along with this, we can also find studies from websites, organizations, and citation searching. So like sir was telling now, we can use citation searching, and suppose we identify 10 or 15 articles from that, we will document that here. So yes, whatever we search like from the reference section can also be included in the systematic review and meta-analysis. It's better to include them. It will be reported in the final study in the flowchart, but it won't be there in the search strategy thing, because This just says what we found from the databases. In this page, that won't come, but it will be included at the end.
Thank you, sir.
You're welcome. If you have any doubt, you can ask, or else we can.
Hello,
Yes.
I have one doubt. Like if we
Yes,
build
sir.
a search syntax and we find very few articles, say 15, 16 article, will it suffice? Is there any criteria for the minimum number of articles that to be there in the search syntax to be able to form that Prisma flowchart?
No, sir, there is no requirement for the search syntax. It's just that we need a minimum number of articles for meta-analysis. That thing is there. But for the search syntax per se, there is no such minimum requirement.
Okay.
Okay, so thank you for the patient hearing. If you have any further doubts, you can ask it in the group. All of us are there in the group, and then we will meet later for the next session. I guess Dr. Sandeep will take. We'll just check it once.
Thank you, sir.
Thank you,
Yes,
sir.
you're welcome. So the next session is on Wednesday.
Thank you so much.
So, yeah, yes,
So the
please.
template will be shared,
You're
right?
welcome. Yeah, the template will be shared in the group.
Okay, fine. Thank you, sir.
Thank you, sir.
You're
Thank you,
welcome.
sir.
Thank you, sir. Thank you so much.
Thank you, sir. Thank you. Thank you so much.
Yes, thanks a lot for the
Thank you,
patient
sir.
hearing. And if you have any doubt, you can ask in the group. All of
Thank
you.
you, sir.
Thank you, sir. Thank you so
Okay.
much. One, two. লক্ষ্য দিতাম হুম লক্ষ্য দিত
আমি কোন আমার আগের নাম্বারটা দিয়ে কোনোটাই নাই
সব নাম্বার আছে
একটাও নাম্বার নাই আমি বিশ্লেষি তোমার
কোন নাম্বার নাই
দেখছেন তো বড় মাসির নাম্বারটা আছে নি প্রতিবার লেখা আছিল আমার এটার
তো বড় মাসে লেখা থাকবে ওটার ভিতরে
তুই বড় মাসি লেখছো তোরটা থেকে দিছো প্রণতি নাইছে প্রতিভা
দেখো না নেই
আমি তো দেখলাম প্রণতি আইছে ছোট্ট মাসি
অনিতা ফোন করছিল তোমার
হ্যাঁ তা আমি তো এটার আওয়াজ কম শুনি না
ফোন করবা
হ্যাঁ ওই যে